Well, thank you. It's always interesting to hear what you're going to say. Let's see here. What I'm going to talk about is what we see as a new paradigm for using computers and networks. And before I really get started there, I want to make clear that this has been a team effort. There's only one name on the slide, but unlike, or to a degree, unlike any other project I've ever worked on in my career, this has been a collaboration of the nth order. I think everybody can see within the project that it could not have happened unless each of those different people's insights had gotten into it, which is really sort of nice considering the kind of project that it is. So what I want to start with here is a videotape of another talk that I gave. It's a very short talk, though it's important to recur every once in a while. This other talk was given at the Round Table in Multimedia. I don't know if any of you have ever heard of the Round Table in Multimedia. It's put on by this business professor at UCLA. This time it was last April when this took place. And it's mostly attended by CEOs, presidents, vice presidents, and senior partners of the real movers and shakers in the multimedia industry, whatever that is. And they invited me to speak, presumably out of ignorance. And you know, a simple country hacker like me doesn't get very many opportunities to talk to CEOs, presidents, vice presidents. So you should really take advantage of such an opportunity, I felt. And so in order for you fully to appreciate this tape, I think it's important that you get out your cigar, lean back. You are CEO, et cetera. You collect quantities of wealth, and you know what the information superhighway would be. I think I'll try and manipulate them here to turn everything on. I get here and I have ultimate control, and having gotten it, I find I don't want it. So we'll turn this on, and we'll try lighting off and see what happens. So far, so good. Yeah.
I'm here today to talk to you about this information superhighway thing, and also to talk about the real world, because it seems to me that some guys at the tops of American companies, some of these guys who haven't even visited cyberspace before, have already forgotten some important things about what the real world is like. But let's start first by talking about the highway itself. There's a great confusion in most of the hype about the great information superhighway. Like the highway was the interesting part. Who cares about highways? Highway engineers do, but not the rest of us. Remember the old Route 66 TV show? It was never the highway that was interesting. It was the people off the highway. All the interest, always. So let's get off the silly page, looking at the people. What about those people? People really into communicating with you. Subvert any technology, no matter how ill-suited to the purpose, for multi-way communication. Programs are enormously popular, from the nationwide syndicated shows like Larry King Live to the small-town kilowatt farm station feature. Whatever the topic, whoever the guest, wherever the station, the lines are jammed with people trying hard to talk to lots of other people. And consider TV. The great pacifier? Not always. A few years ago, a group of German artists and technologists ran an experimental interactive television project visible all over Europe. They patched together all kinds of technologies to create as many ways for people to communicate with one another as possible. In this segment, people could call into the station on their touch-tone phones while watching the program on their TVs at home. Most callers were patched into the TV's audio channel so that they could talk to each other and anyone else watching the program. Others, in groups of 2, were patched into one of these sets of controls for playing on a piano keyboard. These 2 could make music together, responding or not to the comments and suggestions made by those on the audio channel. In another segment, instead of music, 2 of the callers could control a variety of picture drawing tools to collaborate on creating a bit of artwork together. These and the other interesting communication facilities created by the channel's producers were enormously popular throughout the time this channel was in operation. Even with computing, the main point for many people is communication, regardless of the other services available. Consider France Telecom's nationwide video text system, Minitel, originally developed primarily as a replacement for paper telephone directories. One history of the system says, chat services represent approximately 20% of the services offered and one of the most popular services available. Or, the first and biggest of America's online service providers, CompuServe. A spokesman said, any service that involves one member interacting with another is more popular. Or America Online, which, in addition to many other facilities, is electronic host to several mainstream publications, including Time Magazine, the Chicago Tribune, and the San Jose Mercury News. The New York Times said, the real popularity of electronic magazines, in fact, has little to do with reading and everything to do with talking. And talking and talking and talking. Or the massive international internet system, on which, in spite of such data fire hoses as file transfer, World Wide Web, and Gopher, approximately 25 to 35% of all cross-country traffic is strictly for interpersonal communication. Well, that's today. But what do the fancy new online services of the 90s look like? In General Magic's Magic Cap system for PDAs, one place you can go is out onto the streets of a virtual city, where the cute little virtual storefronts are actually rented out to. You can go to the streets, going from store to find the things you want. So, Time Warner teamed up to do something similar in Orlando, Florida, through the technology of interactive television. Again, in their system, you walk along the street checking out the storefronts of, well, in this case, a really well-drawn virtual city. What's missing in both of these systems, and absolutely crucial both to their long-term success and to the mental health of their users? Other people. That's right. You get to walk the streets of these little electronic metropoli all alone. This is a bit like the software equivalent of the neutron bomb. All buildings are still there, but the people have been wiped out. These systems are going to be really depressing places to visit. I mean, everybody just knows, deep in their psyches, that cities are places full of people. You can't help but feel terribly lonely walking these glitzy but utterly unpopular streets. Cities don't look like those systems. They look like this. People there. You can see what stores they're going into, for which ones are the real hot. You can see the same people in 5 different places during an afternoon of shopping, maybe strike up a conversation with them about the best things you saw. The city is a social place, and it's a big mistake to strip that aspect away from it. Consider, for example, some of the visions you've heard about the digital libraries of the future. To me, they sound like this. All those resources, all so neatly and cleanly arranged. Nobody to share your finds with, nobody to compare notes with, no fruitful chance encounters with the other patrons who are scanning the same section of the stacks, not even a real librarian to get help and advice from. Just seemingly endless rows upon rows of electronic bookshelves for you to explore all by yourself. Of course, maybe you're an avid reader of Wired, so you just know that really all these sorts of things will be taken care of by intelligent agents, marvelous simulations of other people. Is this picture really any better? Of course not. We don't need AI simulations of humans on the net. Not when we've already got 250 million intelligent agents in the United States. In real libraries, the very best reference materials are the ones that walk around by themselves. Real, living, and breathing human beings. Whether or not you sit at the same table with anyone, the fact that the others are there with you turns the library into a social space, alive with the potential for interaction. Now, maybe you never go into libraries, maybe you're more of a bookstore customer. Well, real bookstores often look like this. They, too, are full of people. People buying the same kinds of books as you. People at the next table in the attached cafe. People you arrange to meet at this cultural nexus of the community. Look at this picture again. The books aren't really the point at all. They're the excuse. The excuse for people to get together with people. In shopping, the situation is very similar. When someone goes shopping in the real world, they never do it in a ghost town, devoid of human contact. They bring a friend to talk over the choices with. They talk with the shopkeeper about the selection, or the weather. They get help in deciding about fit, matching colors, possible accessories. They get opinions about suitability, about price. They get company. Many shopping trips don't even include a purchase at the end, and most shoppers aren't particularly bothered when that happens. To a large extent, the products weren't the point. They were the excuse for people to get out, meet, and interact with other people. Let's move on to that seeming holiest of the superhighway grails, video on demand. From reading the papers, you get the impression that major corporations think movie watching is a solitary activity, that it's a simple relationship whereby the TV screen puts out the content and the audience just sits there alone in the dark, taking it in. Nothing could be farther from the truth. As was so clear in Cinema Paradiso, movie watching is a profoundly social activity. It just doesn't cut it to be watching Jurassic Park and squeaking out your little signs of distress all alone as the jeep jerks down towards the heroes, one nasty shock at a time. What really makes that experience work is being in a room with other people, with everyone's reaction feeding off of and into everyone else's. The audience in a movie theater laughs together, gasps together, cries together, even if they never look at one another. If you're into this video-on-demand business, maybe you can begin to get the picture of what I'm talking about here, the first inklings of the issues involved. If you realize that the most interesting application is not that my wife and I want to watch a horror movie tonight at precisely 8:43 p.m., but that we really want to watch it together with our daughter, who lives across the country. The movie isn't the point. It's the excuse for people to get together. Over and again, I've made this point. You have to ratchet back your corporate visions 4 or 5 notches and allow your cherished services to be the excuse, not the point. Create your services as places that real people can visit together, and the customers will knock down the doors trying to get in. Bookstores have learned this. Clothing stores have learned this. Libraries have learned this, and movie houses have learned this. Maybe, with a little work, we in this industry can learn it too. Remember the title I gave this talk at the beginning. What is the killer application of the 90s? Simple. It's people.
Thank you. You can all stub out your cigars now. Okay. All right. I imagine some of you have seen some of the hype we've seen recently about one big network. Everything will be connected to everything else. Gazillions of users are joining the internet, et cetera, et cetera. Well, it's all very well that it's growing very fast, but what is it? What is it going to look like? There are two big stories that are getting told. One of them, which we'll refer to as the cable model, says, well, there's you, and there's this vast and marvelous collection of services out there. And you just go and pick them off, just going through the orchard and pluck those trees. Okay? That's one vision. Another vision, which I'll call the telco model, says, oh, no, come on. The net's about connecting people. You make phone calls, you have voicemail and email and video teleconferencing and faxes, and it's great. It's for communicating from person to person. Well, I think that if you think in terms of those two visions, you're leaving out something really, really critical. And what you're leaving out is a notion we'll call joint activity, by which we mean multiple people using the same service from different places. Now, why does that matter? Okay. Let's take a step back and leave aside nets for a bit here and take a look at people. Why do we get together with people to do things? Well, there are a number of reasons. One possible reason is to go to the movies together, have fun, go off, see a nice Katharine Hepburn movie over at the Stanford. It's really nice that you've got somebody next to you that you can turn to and express your awe. We often get together with people in order to teach them things, in order to explain things to them. We certainly get together a lot to collaborate. And here's one you may not have thought of. We often get together without any intent of meeting one another. For example, if I would like to learn how to rollerblade, and now you know just what those funny things are. Those are rollerblades. If the resolution was better, you could see there's little circles down there. If I want to learn to rollerblade, then one of the great things I could do is go to San Francisco, go to Golden Gate Park on a Sunday. There's piles of people there, all rollerblading. And I don't even have to talk to them. I can learn a great deal just by being with them, by seeing what they do and don't do. I can learn a lot about the culture of rollerblading. I can learn what sorts of things are done and what sorts of things are not done. Okay? Now, that's not a comprehensive list of the reasons why we get together with other people, but that's the whole point. There's a whole bunch of reasons, and we fluidly move between them all the time. Okay? Well, what's joint activity look like on the net today? I don't know if we can zoom in at all on these slides, but I'll just point to things here. The pictures are probably good enough. Over here, we have the sort of classic joint work today. We both look at our screens, and we pick up the telephone, and I say, OK, well, now move down to the third paragraph. Oh, no, not including the figure. No, that's the continuation of the second, no, the third paragraph. Right? It's a pain. It's a real problem. It's even worse, especially if you're a system administrator. You go away on a trip. You get a little voicemail that says, something bad's happened. You don't even have a computer. You're on the phone to somebody else. OK, well, it should be booting now. It's not booting now. Is the little red light blinking? Okay. But most of us are doing joint activity on the net in this mode. We're saying, well, now what? Okay. It's not supported. Now, this is a really well-known problem. I mean, computer-supportive collaborative work conferences happen every year. People are designing lots of tools to handle each of these particular scenarios. Let's back up a bit. Let's look at the problem in more general terms. Why is it that it's so hard to do things together on the net and so easy to do them face-to-face? Why is that? We think that the key issue here is the notion of place. Now, what do places get us in the real world? We think there's three key properties. One of them is they get us co-presence. Okay. Co-presence is really useful. Gets us things like easy communication. We have a shared context, so we both know where we are and what we are doing. We have shared access to other things that might be around. Places also give us, through the physical act of being there, they give us this notion of flexible participation. I can be centrally involved in an activity, having great impact on what's going on, or I can sort of lurk a bit, stand off to the side a bit, be a sort of peripheral participant, or I can even leave entirely, knowing that the activity is still going on, come back later and find it. Okay? I have a great flexibility on this axis. Finally, places have rich structure to them. There's stuff there. There's things to manipulate together, things to point at, things to use together. All these resources and connections that we draw between them and appearances that they have that we can share. Okay? There's a lot of stuff. Well, if places are so useful, the obvious thing is, well, let's try and build network places. Okay, cool. What's a network place? Well, let's look at this collaboration scenario, that reason for people getting together. A network place is the third place. You're in your office, I'm in my office, but there's another place where we are conceptually. And that's where we have all the resources we're working on, all the documents, the drawings, the tools. They're all available, they're all shared, and they're all persistent. The state that we leave them in has meaning. And if we go away and come back a week later, they're still in that state unless somebody else snuck in and did something to them. Okay? Now, this is just the collaboration scenario, but it's pretty much similar for all of the other scenarios that I talked about. And remember, what are the three properties we want to be looking for here? Co-presence. There's a strong sense of co-presence in this notion. Okay. Flexible participation. Well, there could be a third person over here reading this collected email, okay, just sort of keeping track of the conversation, might pipe up with something every once in a while. Okay. There's a real possibility here. And then rich structure. We've got lots of good things for making structure in computing, if anything too much. Okay. Now I want to tell you a little story from the future. This URL here is for a paper that we wrote for an issue of the Computer Professionals for Social Responsibility newsletter. They did an issue on alternative visions of the NII, and they asked us to contribute to that. And I'm going to read you one of the 4 scenarios that we wrote up for that newsletter here. So just imagine the future. Another Wednesday night, Mayumi sighed as she arrived home from work. This was always the low point in her week. Wednesday had usually been bridge night for her back in San Jose, but she hadn't found a Portland-based group to play with yet in the 3 months since she'd moved. Determined not to get depressed, she logged on to the new community computer network somebody from work had told her about. She wasn't sure if it was some type of information service, home shopping, or just a bunch of games, but she figured it had to be better than another night of sitcoms. On connecting, she found herself in something called the Community Courtyard, with small live video images of several people, including herself, arranged around the floor plan of a courtyard. The voices of the people nearest her came out of her computer's speaker. "Oh, I really think we should organize a committee to see if we can convince the city to put a stoplight on 17th Street.
Oh, no, they'd never go for it. Too expensive. Besides, a stoplight would just cause mondo traffic jams. What we need is a pedestrian bridge."
Mayumi was bored already. Who cares about stoplights? She was just beginning to think that maybe sitcoms wouldn't be so bad when a new voice piped in. Excuse me, but does anybody know where I might find a local restaurant guide?" Mayumi perked up immediately. She'd been looking for a good sushi place, preferably in her neighborhood. Someone suggested scanning the yellow pages, but a couple of others pointed the newcomer, whose image was labeled Lucia, toward the online coffee shop. A nicely labeled door to it was visible at the edge of the courtyard. "There's a good one in there with reviews and an index on the bookshelf. Even has up-to-date menus." Lucia thanked them, and her video image slid over to the coffee shop door and disappeared. Taking a guess, Mayumi clicked on the door and was pleased to see her own image follow Lucia's into the shop. The sounds of the courtyard disappeared, to be replaced by the soft background murmur of the coffee shop. It was nearly empty just then, with only a few clusters of people in booths. The sounds Mayumi heard seemed like hushed conversations, but she couldn't actually make out any words. She thought. I guess this is one coffee shop where you don't have to worry about eavesdroppers. Then she noticed Lucia's image over in a corner of the room, next to the icon of a bookshelf. She moved over to join her and tried clicking on the icon. a list of the books appeared. The restaurant guide was easy to spot, being highlighted on the list, so she clicked there too, and found herself looking at the French section. Several entries flipped by on her screen, but then the other woman seemed to pause on one of them. "Oh dear, don't go into that one," Mayumi blurted out. "I just tried it last week and the service was really rotten." Lucia's image looked up suddenly and then smiled. "Oh, hello. I didn't notice you come up. Thanks for the tip. I'm Lucia, but I don't see any name on your video." Mayumi introduced herself, explaining that this was all very new to her. Lucia smiled again, nodded, and said she remembered how overwhelming it had all felt to her, too, when she'd first used the net. She showed Mayumi how to put her name on her image, and then they turned back to the guide together, Lucia pointing out a few of the less obvious features of the browser. After a short while, Lucia had made reservations for next Sunday at what looked like a good French restaurant, and Mayumi had gotten a list of new sushi places to try. Their conversation eventually came around to Mayumi's nostalgia for her old bridge nights, and Lucia offered to direct her to one of the local gaming lobbies. "Well, I don't play bridge myself," she said, "but maybe you can find some other players there." Mayumi quickly agreed, and after being shown how, let Lucia take her hand and lead her along the way. They passed through a number of interesting-looking places before they got there, and Mayumi jotted down a couple of notes to herself, meaning to come back and explore more later. When they reached the gaming lobby, Lucia said, "I don't play games much myself, but I've gotten good at finding this particular place. My boyfriend is a chess maniac. He just loves the portal they have here to the net-wide player rankings. I'll look for him in the chess room later, but first let's find you the bridge room." When they consulted the map in the lobby, Mayumi was just amazed at the size of the complex. There seemed to be a separate space for nearly every game she could think of, and several others besides. Lucia explained that each room was heavily customized by its aficionados, with pointers to net-wide resources, tournament ladders, reference works, and so on. "It's really impressive how much they've built for some kinds of games," she said. They found the bridge room in the index and had the map walk them along the halls to the right place. Lucia then said it was time she went to find her boyfriend, but invited Mayumi to meet them later in the coffee shop. Mayumi thanked her for her help, and they agreed on a time to meet. As Lucia waved and her image slid off down the hallway, Mayumi entered the bridge room. She was a bit taken aback. The bridge room was all Lucia had said it would be, with all kinds of useful bridge-related paraphernalia practically littering the space. She looked at something called the events board, on which she discovered an announcement for an amateur duplicate tournament 2 months later, right in downtown Portland. "Great," she sighed aloud. "Now all I need is a partner." "Well, you've certainly come to the right place, haven't you?" A male voice broke in. Mayumi jumped a bit. She hadn't even noticed among the clutter that there was someone else in the room. Hello, Rich," she said, reading the label on his image. "I'm new here. Are you looking for a partner then?" Rich laughed and said no, but he directed her to the Players Seeking Partners Rolodex in one corner of the room. Clicking on the icon brought up a simple database interface, and Mayumi soon had the name and email address of another woman who was new to Portland and in need of a partner. At Rich's suggestion, she wrote a quick note to the woman, inviting her to join Mayumi for an evening of bridge on the net. "Well, that way you can see if you're compatible before committing to play a whole tournament together," he explained. Mayumi thanked him and then logged out of the system, sighing once more as she leaned back in her chair. Only now, it was because Wednesday night was over, and so soon. Well, if that's the kind of places that we're trying to build, we have a great deal to learn. Some interesting questions come up. How close can we come in a network place to the real life qualities of co-presence, flexible participation, and rich structure? We need a lot of experience. In order to get experience, clearly, we need to build some prototypes and observe their use. Well, some prescient folks 15 years ago started creating MUDs, not realizing that they were a prototype for the network of the future. At least I don't think they were aware of it. MUDs have been around for about 15 years. They started at University of Essex in England, primarily as a way to play Dungeons and Dragons with a bunch of friends. There are now hundreds of them accessible on the internet. Each of them has between tens and thousands of users and tens to thousands of network places or rooms inside them. Now, they're completely textual. For those of you who haven't seen a MUD, all you get is plain ASCII text, nothing else, not even a font. Okay? They're self-contained worlds, too. They tend to be very isolated. Everything about the world happens in the world. Nothing from outside comes in or goes out except through the agency of the humans themselves. Well, they're used for, mostly out of their background, games and socializing, but increasingly also for teaching and collaboration. As a few examples here, MicroMuse has been around for a long time. It's being run out of BBN and is a center for education for young kids. BioMoo is a technology collaboration center for professional biologists run out of Israel. MediaMoo is another such center run out of the Media Lab at MIT. InfoPark's an interesting one. It's a MUD used at the Northeastern University College of Computer Science only by the system administration community. There's about a dozen of them, and they're spread all over a large building. It's the only way they can keep track of one another. PMC-Moo is kind of interesting. That's a postmodern culture Moo associated with Postmodern Culture magazine. I haven't actually been there, but I have this vision of English professors cavorting. The interesting thing about MUDs is that they're collaboratively and continuously being constructed. Everyone who goes there creates new things, explores what's there before, is inspired, and creates new. Okay? They're constantly being reconstructed all the time by the users. Now, these are very crude systems. They're very restricted. All you've got is this text channel. You have to type in order to communicate. But still, if you talk to anybody who's used one of those systems, there's a very strong sense of co-presence. Flexible participation is the norm. People move between lurking and being actively involved constantly. And there's a lot of rich structure there. There's a lot of stuff that people have built that does things. Interesting prototype. The other prototype I'm going to talk about is the Jupyter system that Victoria was mentioning. And I have these little teeny screenshots, so you just have to get the idea. Oh, but maybe we'll be zooming some. Oh, yeah. My word is his command. Cool. OK. Let's skip the notes here. Jupyter is built on a mud foundation, so to speak. I always think of that part of Monty Python where he builds the castle in the swamp and it sank and he built it again and it sank. Anyway, Jupyter is built on top of the same server that LambdaMoo runs, which is the MUD that I run at Park. And the text window that sort of shows what would happen in a normal MUD is still there. It's actually hidden back here behind this other window. So that's all still there, but there's also some other interface. So there's a name and description of the room that you're in and the exits you've got from this room and who else is in this room and the other objects that are in this room. And it's all point and click and very GUI. There is this tool called the Communicator, which allows you to see and speak to the other people who are in the same room. So you can see their video, and there's a press to talk button and so forth. So you have that channel of communication as well. OK, now, this is a different room in Jupyter. Let's zoom here. And it happens. It's great. OK, we still have that main window back up there again. And here's the communicator. We can now see that there's other people in the room. There's a few different people. This one's highlighted. I think you can barely see that because that person is talking right now. There are some labels here for people who don't have video. We support a variety of capabilities. But there's a few things that are just in this room that are related to, this is a project room. This is a laboratory for the Jupyter project itself, actually. We have a whiteboard that people have been drawing on. There's a bunch of documents and recordings and so forth. There's a little browser for recorded meetings that we've got. There's even decoration. Our favorite Roz Chast cartoon from The New Yorker is there in the lab. Let's see here. What else was I going to say here? Oh, important thing to note. Everything here is persistent. Everything here is shareable. So this is a shared whiteboard. You notice there's no save button. Nothing has a save button in Jupyter. You just draw on it and then drop it, just like a piece of paper. OK, everything persistent, everything shareable. Next slide here. OK, so there are a number of forms of textual communication in Jupyter, including the ones from the MUD heritage, but also some new ones, such as Post-it notes, which you've probably seen in other systems. This is a fairly unobtrusive one. It's nice to use when somebody's not in their office. Just leave it on their screen. Whenever they come back, it's there for them. Also, if they do have somebody in their office, which you can see with the video, you can sort of toss that up there, and maybe they can take a glance at it out of the corner of their eye and realize that it's not that important, and you can get back to them later and so forth. And just a nice little halfway between email and direct speech communication. So in this case, we're being asked to come and help out somebody who's having a problem with another piece of software. So when we switch locations to go join them, the things that were in the other location, such as the decorations and the recording browser and the whiteboard and so forth, go away because we're not with them anymore. And some other things pop up that are in the new location. So one of the things here is this Gopher browser, which works on the real Gopher system and, of course, is shared and persistent and so forth. There's also a shared Unix shell up here that is showing the tool that the person was having trouble with and wants our help on. So you can see there is a little bit more of external connections in Jupyter than there are in the average MUD. It's gotten a little bit more connected to its world. Not much, just a little. One more example is there's a fax machine in Jupyter. It's a real fax machine. You can really fax things into it. It creates documents that are then these shared pictures that you can manipulate inside Jupyter and show to other people and so forth. And small matter of programming to go the other direction, but we haven't got around to it. OK, so what's up with this Jupyter? Well, clearly the most obvious change from MUDs is that it's got multimedia. We've got text, and graphical user interfaces, and audio, and video, and all that stuff. We intended it as a place to do professional collaboration using this sort of a system. We like to say it's a kind of net workplace as opposed to a network place. OK, forget it. Tough crowd. So we started out as a research prototype, but it's actually gotten stable. It's in use by 40 to 50 people pretty constantly. An interesting thing about it, unlike systems like, say, ProShare or ShowMe from Sun or something, this isn't a way of making a telephone call to somebody. You don't get a connection to them and then use these tools and then go away. This is a system you live in. People stay connected to Jupyter for weeks, months, generally only getting disconnected when we have to reboot the server for one reason or another. So it's got a different sense. People drop by and then go away or just hang out. It's a different sort of system. And we're currently, as we say in corporate speak, we're exploring options for distribution and commercialization of the prototype, which means we'd really like to release it, and we're getting close to convincing the corporation we can do that. I want to give just one quickie technical, semi-technical overview of how the Jupyter works. There's a main server, which is an unmodified LambdaMoo server. It's got a programming language interpreter in it, which is where it spends all of its time in this simple interpreted language. And then there's a persistent object store, an object database, and it's got base classes and libraries of useful stuff, and also the objects representing all of the tangible things that are apparent in the universe. People, places, things, that sort of thing. Each client is running on a different machine, connected by TCP back to the main server. We have clients working for several varieties of Unix and Microsoft Windows, and we're hoping by the middle of next month to finally be able to demo the Mac client. And there's also a few special servers off on the side that have connections to the main Jupyter server and handle things like recording and playback of audio or bulk data storage and retrieval and a few other useful services. All of these things out the other side of the client's mouth, as it were, are speaking IP multicast, and that's where all of the audio and video goes. So none of that high bandwidth stuff is going through the main shared server. It's all taking this broadcast thing. The server is controlling where it's going. All of the network traffic, both the TCP and the multicast, is encrypted for privacy. If anybody would like to talk about US export regulations, I'm more than happy. OK, so what have we learned from these places? Well, the first clear thing is that people really like these things. People really like network places. They're very compelling. For example, LambdaMoo, the public MUD that I run at Park, has over 9,300 users, and we're pretty active about getting rid of inactive accounts. So those are active users. Last I counted, there were 54 countries we'd gotten connections from. And there are almost always more than 200 people connected to LambdaMoo at any given time. Even at 4 in the morning, there's at least 100 people connected. Sort of frightening. And if you have a really, really fast computer, I'd like to talk to you. There are about 7,000 rooms inside Jupiter built by the users. And the place has gotten a strong sense of community to it. People bond together there. They meet. They get engaged. They make friends. They get resources, social resources from the place. It's with a certain amount of shoving from the outside. It's adopted a formal self-government system that works, more or less, as well as any of those things ever work. It decides on things like community policy, how to manage the shared resources that are there, and there's a whole dispute resolution mechanism. People are engaged. They're there. The second key lesson that we've learned is it has to be very easy for people to build things. Otherwise, the system won't be rich enough. You need to capitalize on the user community to create the world. But it's got to be very hard to destroy their work. Otherwise, they won't bother, right? LambdaMoo itself is built and programmed by its users, as I said. There's a wide range of ability. Some of those people are malicious. Many of them are incompetent. If you're the person whose code is under attack, it's often difficult to tell the difference. And unless the system is stable, you won't bother to build. We find a lot of MUDs die because they keep going down. LambdaMoo, I always had a commitment to robustness, and people built. The programming language in which you build has got to be simple, both to read and write. It's got to be robust. None of these picky rules about, OK, well, he allocated the storage. That means you have to free the storage. And it's got to be secure. It's got to have a fine-grained access control because you have lots of people's code all mucking about together so that it's safe to call each other's code. There's a huge amount of it in LambdaMoo, millions of lines of code written by the users. Many, many programmers, probably 5,000 programmers. A lot of tightly coupled intercalling. Code from one user is calling code of another user all the time. And minimal trust is about all you can afford because some real nasty people are there. Okay? And the whole thing's got to be very lightweight so that people can just do things. This physical metaphor is really valuable. Boy, is it intuitive. Gosh, that's great. And it's really a pain to figure out how to apply. For example, in Jupiter, you can only see and use the objects that are in your current location, as the whiteboard example before. And all of the objects are persistent and shareable. You never have to think about that. On the other hand, what is an object, anyhow? Is my map an object? Well, I guess I can sort of understand you're looking at a map, but when I push on it, it moves me somewhere. What about a code editor? That's an object. There's this thing that I'm... And what about the communicator? That's my favorite example. Currently, it's a separate tool. I have this vision that there are 5 people all in a room. They aren't looking at one another. They're staring at this tool so they can see and talk to one another. Something's wrong. Okay? What about non-local reference? We know these are computers. I don't care that the bookshelf is over in that room. I'm here. I know where the book is. I just want to see it. I don't want to have to drop all this context, go over there and get it. On the other hand, that's a really good place for it. And of course, the issue always comes up of what about being in more than one place at once? Great idea. How do you present it to somebody? When 2 people from 2 different places start talking to you at once and can't hear one another, it can be very difficult to manage. Lesson 4, you don't have to wait. Current networks, current CPUs are just fine to support pretty good, pretty useful video. What I like to call crappy video. Okay. We're just using Spark 2s, Spark 10s, that sort of stuff. We have PC and Mac clients, as I said, coming along. No special hardware on them, just a video grabber. We're using normal network technologies. We're even using ISDN. When we work from home, we get to see all the audio, all the video, share all the tools, just same experience, all over an ISDN line. IP Multicast, a lot of people throw stones at it. It works just fine for us. You don't have to wait for this stuff. You don't need full motion 640 by 480 video to be useful. Right? 1 or 2 frames a second in a postage stamp 80 by 60 pixels is terrifically valuable. I have a sense of co-presence when I'm at home working with this system, and I only have postage stamps to work with. I know if the person's there. Are they on the phone? Do they have a visitor? Are they on task? If I say something, will they be paying attention? That's terrifically valuable. As I like to say, we're bottom feeders. We didn't actually develop any audio technology, any video technology. We just picked it up and used it because apparently people didn't realize how useful it could be. 5th lesson, very important. Security is important not just to system designers, it's important directly to your end users. They have important, deep, basic questions that they need to know the answers to and be confident about. Is it safe for them to use some object they just discovered? To read a note, to pick up an object that they've never seen before? It better be. It better be safe for them to visit places they've never been. You can't hijack them or do damage to them. They better be able to call unfamiliar code. Let's get down to brass tacks. Okay. It has to be safe for them to let others do the same things to them, use their objects, visit their places, call their code without doing them damage. And very importantly, if you're going to represent them as being in a room with 2 other people, it had better be the case that only 3 people in the whole world know what happens in that room. So what's the vision? Network places become part of the network infrastructure. They're taken for granted. Everything in the net is located. It's in a place. You can go there with other people, encounter them on purpose or by accident. And anybody can build and configure and link together new places and explore the public ones that are out there. Now, does this sound familiar? To me, it sounds a lot like World Wide Web. If you just put document instead of place. Okay. It's not bad. It's got all those nice features to it. It's got a real good spirit. It's not the thing we're after, but it's got a good spirit. We should be inspired by it. Okay. Okay. It's time to move past prototypes. We are beginning something we call the Fabric Project. The intent is to do network places for real. We're talking about millions of servers on the order of 1 per user on average, though many people, just as they currently use somebody else's machine to get access to the net, will also be using their server. Netcom will have a big Fabric server that people are sharing. Almost all server boundaries are also trust boundaries. I can't trust your server. You can't trust my server, because some of us out there aren't very nice. And some of those trust boundaries are in the middles of servers, like the one that Netcom runs. They have to protect their users from one another. We need some notion of an unforgeable URL. I don't know if it's really a URL, but it's an identifier for something that acts as a capability. If you don't have it, you can't get it unless I hand it to you. You can't just make it up. You can't guess it. We're going to use authenticated and encrypted TCP links at the very bottom of the system, always. No exceptions. Because there's hardly any time in the emerging internet when you don't want encryption. When we start hearing stories about people who happen to be on transit nets for links, and they watch you set up your TCP connection, and they watch you use your fancy one-time password system, and you log in and you're all authenticated, and then they just sort of step in front of your packets and take over your TCP connection. Well, you better have encryption and authentication on the wire. Rarely worth being an option. You need to be able to execute other people's code locally. You want to bring it from the far side to your side and run it. Could be running the user interface and you want responsiveness. Could be doing various kinds of sort of query optimization. It's giving you better service for some remote service by doing caching or handling certain kinds of query modifications locally, et cetera. It's sort of a load sharing, load balancing idea. That means, since you don't know this code from Adam, you've got to be able to run it in some sort of encapsulated execution context. And that doesn't just mean a different initial environment, a different set of facilities available. It also means I can control how much CPU, how much space it uses. So that when it runs out of time, the amount of time I thought was reasonable for it, I have an option. Blow it away. It doesn't seem to have done anything useful for me. Or looks like it's almost done. Give it another minute. Okay. Now, if you talk about this sort of thing to traditional mainstream computer scientists, especially database guys, they just laugh and laugh. You are on big drugs. Millions of servers. Oh, yeah, sure. But this isn't the database problem. This is not the distributed database problem, because we don't need global consistency, right? Bilateral contracts are the way you're going to go here. Suppose that your server runs some region, some room, and I run some object, and the object would like to be in your room. Well, some programmatic negotiation is going to happen, and we're going to come to some agreement that this object will appear to be in your room. I'll sign up for that. You'll sign up for that. We'll have an agreement. You don't care if I also have such an agreement with some other region over there. We don't need any global, consistent notion of where's that object right now, and everybody's got to lock and hand off properly and so forth. It just doesn't matter in almost any case. What matters is very local consistency, and that's not hard. Okay? Most objects in particular aren't very busy. Most web pages, nobody ever browses except the guy's family. Right? There are some exceptions. Imagine the network place that's trying to be Shea Stadium. A lot of people might come there, but there are traditional techniques for dealing with large, highly available, highly robust systems. Let the people who run Shea Stadium put together 100 servers that are mutually trusting. Let them do whatever kinds of consistency protocols are appropriate behind the scenes, but the main protocols don't make any difference to you. Okay? It doesn't have to be part of the base architecture. Okay, got to have a language here in which we're going to develop things. I choose to call this one Fable, for fabric languagey. We need all the things you get out of object-oriented programming languages. Code reuse is terrifically important on LambdaMoo. People inherit from one another's code all over the place, and that's what makes anybody there productive. It's also one of the best excuses I've heard of for multiple inheritance. Think about 5,000 uncoordinated, individually uncoordinated, but also group uncoordinated programmers, and multiple inheritance makes a lot of sense. Clearly, you need encapsulation and polymorphism for security, just so nobody can really see what's behind the wall. It's got to be message-based. Obviously, these handles on remote objects are going to be very common, these unforgeable URLs. You're going to have pointers to objects on machines all over the net. If it's a distributed system, it's going to be concurrent. It just happens. So there's going to be a lot of concurrency all over the place. In particular, it comes up in new places. Whenever you call somebody else's code, you'd better not wait very long for them to get back to you, because they might just say, I wonder how long you'll wait. And of course, if it's also concurrent within the system, then it helps your local scalability. It's currently getting difficult, for example, to find a machine fast enough to run LambdaMoo. It is sobering to realize that if I were to go buy a top-of-the-line Cray, it would not be fast enough. And the reason is that the LambdaMoo server doesn't have any vectors in it and is only doing one thing at a time. It's a single-threaded application. I kind of wish it wasn't a single-threaded application, because then there's lots of machines I could try to use. But, you know. One of the things we learned from LambdaMoo is that persistence is a great onus to lift from a programmer. They should never have to think about, I think I'll have a checkpoint now so that I'm sure I'm consistent. Right? Just got to take that off of their back. Anything they write to anything is persistent. If you must label things as exceptions. We actually do have some interesting little difficulties trying to restart Jupyter, because it always comes down, well, it comes down at a reasonable time in a reasonable way, but there's all this funny state left over, and there's this great mad rush at the beginning of the server boot to try and go and clean up everything before any user connects. So maybe some exceptions to make some things less persistent, but mostly ubiquitous persistence. We're thinking about languages to start from here. Maybe Self, maybe Python. Leading contender at the moment is this thing called Oak out of Sun that they're running with this web runner active document stuff for a number of sort of dull technical reasons. We're still looking for candidates to start from. We don't think we're going to just find Fable lying around, but we'd like to not start from scratch either. OK, so where is it? We haven't started yet. Not a line of code has been written. Not one design document has been written. We've talked about it a lot. That's why we call it Vaporware. As soon as the Jupyter release is resolved, which we're hoping happens this month, in March, then we intend to begin work on it in earnest. At some point, when we get to the right stage, and I used to have dates on here, but my collaborators started freaking, so I took them out. I want to have us up to a level where we have basically the functionality of a MUD. You walk from place to place. You type to talk to people. Just a simple computational foundation to start from. And then do a big test. Say 10 to 20 servers, distributed as broadly around the world as we possibly can to make latency as awful as possible. And try it out. See where you have to move code around in order to get performance. And most importantly, to try out security. It's my hope that at the time that we do that, we will publish far and wide on the net, even to people who aren't involved in the 10 to 20 sites, what all of the protocols are, and where all the machines are, what all their IP addresses and everything are, and invite the net to break it. We'll, of course, let the testers know that that's the point of this test, and they shouldn't put anything really important on those servers. But I want us to put it to a real acid test. Offer money. If you can break it, we'll pay you. I think that'll get a few people to try. Okay. And I'd like to know that before there's tens to thousands of these things and it shows up on the front page of the New York Times, you know. What's that? Yeah, all right, Mitnick's in jail, so we don't have to worry. OK. What about his evil twin? OK, after we get to that point, I think it's straightforward to put in the sort of other facilities that are in Jupyter. Mostly, it's porting known solutions for the audio and the video and GUI stuff. The Jupyter project is continuing even after the release, mostly in a new mode of trying to get a large number of serious users, support them directly, and learn as much as we can about these user model questions that I mentioned before, what makes such a system useful, try a lot of experiments, so that when the time comes and the fabric is up to a certain level, we can do much better than Jupyter in porting it over. When the time comes for the real release, the idea is to follow www's growth curve. We want to take over the internet. It's that simple. Towards that end, we're thinking now about how to convince a corporation like Xerox to let us do that, how to work with the right people to make the communication standards, how open can we possibly be, how free can we make the initial server and client. Because this is pretty valueless unless everybody uses it. That's the goal. Never again will you have to use any service on the internet alone unless you want to. Thanks very much. So.
We don't not keeping track of time here, but I'm sure we have got time for some questions.
Okay.
I got a soft pitch for you. Would you comment on the merits and demerits of using a language like, say, C++ for doing something like this, and what a reasonable corporation who's trying to build something insanely great like this would want to do?
First question first. C++ makes a large number of assumptions we think are not good for this environment. There's no support for concurrency. Persistence is problematic. Storage management is very problematic. Safety is very problematic. Remember, you're importing somebody else's code. You have to be able to check before you run it that it's not going to screw you. And you don't want to write a new operating system with special memory management techniques and so forth. It's also, I think, in certain ways too complex. I know I found it very daunting that as a programming language researcher who's written several compilers and did a thesis on type theory and so forth, I think I've got a certain level of expertise, and I came to the ANSI standard for C++ and was unable to make it through the binding chapter. I couldn't understand the scope rules. And I challenge anybody to answer certain hard questions about C++ scoping. So I think there are a number of problems with trying to use any of the existing languages along a number of different axes that I've mentioned. These are things that people don't put into programming languages by and large. Capability security is another thing that's sort of lacking in C++. Let's see, the other question. Oh, yes, what should other companies do who are thinking about similar sorts of things? Oh, you should give up, clearly. We're way out in, no. We should talk. I'm starting the process of convincing Xerox that this has to be a standard and has to be open. I'm not finishing the process yet, which is pretty good for a research project that hasn't started yet. I think there are a lot of agreements that could be made and a lot of work that could be done together as the process goes ahead in terms of communication standards and language standards and so forth. The tricky part is trying to do much deeper things than that because it is a research project. It's not a done deal. We have a lot of ideas that might not work. And trying to do development among several companies all at once is tricky. But the best first step is clearly to talk. So should you happen to know of any large corporations with similar things, you might have some representative come and talk to us. Other questions? Yeah.
Can you talk about some of the changes, social changes you saw in moving from text-only MUDs to Jupyter? And in particular, did you find that there were fewer persistent objects created by users and less control over the types of interactions? Like in MUDs, people create rooms with various kinds of access control where you can communicate in various ways. They do, remote paging and all these things. Are there equivalents to those that have evolved?
Yeah. The first interesting thing along those lines is that we expected text more or less to wither away. We figured, well, textual communication, I'll use it for giving you a URL or a file name or a phone number or something, but mostly it's not very much use if you've got audio. But it's not true. Post-it notes are fabulously popular, precisely because they span a synchronous to asynchronous boundary. They're so low overhead, you can take a glance at them and see if it's going to be real important, and you can't do that with audio very well. The other thing that happens with text is that it gets used as a side channel. You're having a conversation, and somebody who's only peripherally involved in the conversation doesn't know what that acronym that everybody keeps using is, and they ask a question in the text channel. And somebody who's not in the middle of talking at that moment types the answer, and the conversation continues without interruption. Or somebody wanders in and asks a question, and the same sorts of things happen. It happens a lot. In terms of persistent objects, we find at least as many in Jupyter as in other systems. Because we have these really easy tools for building shared tools, that shared whiteboard application, for example, is 29 lines of code. Our shared text editor, I'm proud to say, is 0 lines of code. And I can explain that paradox to somebody later. It really does inspire people to say, oh, God, what I need is this little tweak. And only me and my work group would find this useful. But in fact, it's only 50 lines of code, so I'll just go ahead and hack it together. So we find that people are creating a lot of things. And some of the generics that we've created, such as whiteboards, Gopher browsers, text editors, bookshelves, a number of other things, are real popular. And people go to the vending machine in the lobby and take them out lots. In terms of access control, we're finding as we move away from it being a prototype used more or less only by friends of the project and into people who are trying to use it for real, that people are more and more concerned about access control. They would like to be able to lock the office that contains their stuff. And in fact, LambdaMoo doesn't support that terribly well. It supports it sort of OK. But we're looking at a lot of the code that's been written in a lot of moos to get locked rooms or immovable objects and so forth, and try and pick the best ones and turn them into idioms that people can easily apply. But they care about it a lot. Yeah. Question back there.
Language substrate. What are those 20 lines of code written in?
They're written in Moo. LambdaMoo has its own little interpreted language, which is kind of a little object-oriented language with some vestiges of C syntax, unfortunately. I can show it to you. It's just a simple interpreted language. It's a lot of fun, actually, except when you run against the sort of dark corners where it's actually not quite sufficiently robust or general or precise in certain places, because I didn't know that's what I was designing it for at the time. Most of the time, it's just great. You have this wonderful immediate gratification as you whip together a tool and it starts working immediately, and then you hack some more code and the other button starts working, and you hack some more code and it does this too. It's just, you can hack for hours on this stuff. It's great. Yeah?
How do two people communicate if their object hierarchies are different?
In the fabric, in Jupyter?
In Fabric.
The protocols don't have to do with object hierarchies. They have to do with method suites, with method interfaces. So I don't care how you inherited your code. And to a large extent, I don't care about your type hierarchy. I care about a hierarchy of behavior. Inheritance is your job, is your problem. It has to do with your making your coding as good as possible. But the interactions between objects don't have to do with that. They have to do with what are you pledging, what contracts are you claiming to support. So in fact, the issue of object hierarchies doesn't come up at all.
That means I have to have a published API for every single object I want you to be able to see. And I have no way of collecting those into useful taxonomies. That's
not clear. There is a hierarchy of APIs, for one thing. I simply hasten to point out that that's not the inheritance hierarchy. It's independent. And to a first approximation, for most code, yeah, you've got to know about the API you want from this object. And there are a number of standard ones. You know, I'm a generic object. They all support these things. I'm a tangible object. I have notions of location, movement, and so forth. You know, there are a number of these interfaces, and there's a mechanism for querying an object about just what interfaces does it support. And the intent is to use the standards process to create new APIs and query about them and so forth, and have code that's willing to cope with, that's an ancient object.
And one final point on that is, how do you see this problem scaling when you have millions of users?
I think that standard APIs will come out relatively slowly. I imagine them coming out through something very like the IETF or ISO. But I also imagine a large number of ad hoc standards arising, sort of like the X hyphen fields in mail messages where people add in new things. And I don't think in general it's a problem, because the fundamental protocols that you just have to know in order for this object to get there in the first place are relatively general and allow for things like, what are the commands you support? Select one, do it. So there's a certain amount of reflection, a capability there that gives you some escape hatches out of knowing in advance what all the operations are. You think of that being like MUD objects, which have commands on them, and there aren't any set APIs, but you can ask the object what commands it supports and get some hints about what to do with it. So there's a certain amount of meta level stuff to let you inspect what's going on. That's also important in code that moves across the net. It lands on your machine. It needs to know, OK, what do you got here? I really need the ANSI standard string library. Do you have it? OK, fine. I know where to get it. I'll get my own copy. Thanks very much. Yeah.
We just have just one more question, because it's nearly 20 minutes after agenda.
Uh-oh. And it's not hidden agenda. It's right here. Yes?
Just the question is code itself an object in the system?
To some degree, yes. That's my current guess. I mean, I have to append to all of these things. Not a line of code has been written, not one design document has been written, but we have a lot of ideas. In LambdaMoo, yeah, but only in a sort of dull way. A list of strings can be installed as code, sort of the same way that it could in Snowball. So nothing very deep about it. In particular, no nice operations like walk the parse tree, et cetera, et cetera.
Val would be nice.
Right, right. You've got that, but only at string level, not at language level. Well, thank you very much.